So, firstly, thank you all for inviting us to this particular weekly chat. So today is the purpose of this presentation is very quickly just to kind of give you an overview of what we're doing or how woodworking for Inventor would suit your business needs going forward. I'm joined by my colleague, Tobias Anderson, and he's going to co-present this presentation with us. And this is a mixture of some text, some presentation slides, along with some video files as well, delving into the product a bit more. So firstly, the basis of woodworking for Inventor is basically built around Inventor itself. And what is Inventor? Inventor is very much a parametric 3D modeling tool. It's got numerous features like associated 2D manufacturing drawings, rendering engines for visualizations, for example, bill of material exports, sheet metal, and a lot of rule-based designs around our logic, which you're going to see through some of those video files that as I go through the presentation. Tobias, you're up.
Perfect. Yeah, so thanks very much for joining us, guys. So basically, what is Woodwork for Inventor? So it's specifically designed really for the woodworking industry. It sits within the Inventor environment, within a wee ribbon of itself, and it's similar time, takes about similar time to kind of create initial models within Inventor, but it's really designed to speed up the process kind of post the initial model generation, and the automation of cutting lists, bill of materials, and interfacing with a variety of different CNC machines. So just to walk through the workflow. So usually you start off with a skeleton model. So this is just the bare essential parts, features, and generic cuboid shapes in places of doors and drawers, etc. Then what you do is you utilize the iBox function to fit components from the library that you have within Woodwork for Inventor to the previously generated shapes, doors, drawers, kind of choosing 3 relevant points to assign each of those components. Woodwork for Inventor then comes with a wider variety of woodworking materials additional to that's already available within Inventor. So you have the ability to change the material on a global scale, which we'll show later on in the presentation. When hardware is added, for example, automatic sculpting is used to remove material for you. So that's for hinges, different dials, etc., like that. We'll show you again later in the presentation. But it's all linked and parametric. So any updates to changes to the skeleton model will be pulled the whole way across. It also has its own separate BOM or bill of materials from Inventor. It pulls out reports, cutting lists, edge banding lists, pricing, costs, all kind of bespoke to what you guys would need it specifically for your requirement. There's also a feature called AutoPlot, which once the initial configuration is set up for your own requirements, it then generates all the drawings for you. So it will generate the drawings for the specific parts and for the assembly, and you can then make your own tweaks, changes. For example, if you wanted to get some specific drawings or dimensions out of it, you can do that at that stage. It also interacts with CNC, like we mentioned before. It has its own range of CNC G codes built in already. And again, this is separate to Inventor CAM, which is an Autodesk product. But yeah, it's all stored against the model itself, so you don't actually have to export it elsewhere. And again, everything's updated across the board. That's one thing that I'll kind of mention throughout this presentation. Once one change is made, everything ripples through. And then finally, there is a nesting tool there as well, yeah. And again, separate from Inventor nesting, it's built into the model. So when you save it, everything's saved together, and obviously it's useful for the optimization of raw material.
Okay, as part of this, we're going to just show snippets of that particular workflow. And this is the first part of this workflow where we define the skeleton model, which is basically just the overall size and shape of the unit or the cabinet that you'd like to make. We very much heavily populated with parameters. You can see here we're just building kind of a solid block, which is kind of an overlay or a general shape and size of the actual model you want to use. With that in mind, though, however, we make it parameter heavy. What I mean by that, we make it smart, we make it intelligent, because we're going to reuse those parameters quite a lot throughout the build of this particular unit. You can see here we're putting in parameters such as other panels. We're going to put in some define the drawer quantity, for examples, the shelf quantity, the spacer offsets, all that kind of important and relevant information that controls a parametric model ultimately. So with that in mind, once we've built the overall shape and defined those particular parameters using woodworking for Inventor, we can then use a command called dress up. And dress up basically builds the unit for us, as you can see here. So very quickly what we can do, we select the dress up command, we select the faces, we select the orientation, for example, we apply to all faces, and we build as such. Again, you can see I'm utilizing the parameters that have been defined and already predefined, and there are my boards being put into place already. We can define the thickness, we can start trimming off and hiding and controlling what we look and see. We can actually list parameters and build up panels as we're doing here now at the minute. And we're actually going to mirror that on the other side as well. So you can see we can actually put in panels pretty quickly and easily, defining off those parameters. One of the most important things as we build up these models is the actual, how we can trim those members back to suit. So for example, you can see there's interference between those boards, as you can see, or the carcass, as you can see here. And what we're trying to do is make sure that we can apply for those miters, do all the finishing work here, and you can see it does it automatically and applies to both bodies. And again, what we can do is we can come along here and we can actually look at the boards, trim back the boards to suit. So we're using the simple direct edit commands here to pull and stretch boards as we need, or panels as we need. And again, defining by the parameters here. You can see in this case, I can snap and reference off faces from one panel to another to actually get the fit, form, and shape of that particular unit. Finally, then what we're going to do is we're going to look and kind of sketch and do a kind of predefined sketch to locate where the drawer and the door positions will be in relation to the particular unit. So you can see here, I'm just defining a very quick sketch and putting it into position where the door would sit in relation to the unit. And also I'm going to do the same. And you can see I'm just building up a quick panel, again, controlling and creating it as a solid body. Moving on to the next part, I'm now moving on to the middle section where I'm putting in the drawer panel. So again, I'm reusing geometry that's already built from the model. I'm just referencing that, defining my dimensions, for example, and then defining those parameters as well. So again, as you can see, as I'm building up this dimension, I'm naming them for reference, which can be consumed downstream within the workflow as well. So again, in this case, what we're doing is we're just putting the information in place and building up the solid, and then we should be able to move on from here. Okay, so that's the layout of the drawings. And we build up the solid and we close it out like so. So now you end up with a kind of a solid body that's already ready for the next stage of the workflow. So you can see here we have solid panels put in place. We've built up the carcass. We've built up a layout of where the door position and the drawer positions are going to be. Now what we were going to do is we're going to move to the next step. And the next step is actually making it intelligent, putting in those drawers directly into the model live as we speak and pulling that information from a library. So you can see here, but just a quick graphic that I did, you can see as we expand drawers, as they size, the components that make up those drawers also adjust in size to suit. In this particular example, what we're doing is we're looking at that particular carcass that we built up. We're now converting that into an assembly, and we're working directly within the assembly environment. We isolate the components to the actual drawer positions and the door positions, and pulling from a library, we can actually pull that information directly from a library, and you can see we can size that information on referencing those bodies in position. So you can see in this case, I've just pulled the drawer in, I've selected the side face, top face, and the front face to give the overall position. And I'm doing the same for the door. So again, for the front panel of the particular drawer as well. So once I have that in place, now I'm going to move to the door. So I can specify the type of door, what type of door I want to use. Put the door in position. I can select the top, front, right, and left sides of the actual panel that I've just put and position that door in. It will stretch to suit that particular size as well. But in addition to that, what's most important is we can open up that, isolate the door, and using iLogic configurations, we can configure that door independently of the rest. So where it hangs and so forth like that, window size, etc. So that's all built in directly within the Inventor for Woodworking environment. We now move on to where we can actually start patterning the shelves and mirroring the components over to our site to complete the unit out. You've got to remember, this is all parametric, so this will change to suit. The drawer will suit to change as well. Finally, what we're going to do is we're going to put in the door and we're going to mirror this across. Tobias has said it already that this is all parametric, so you can see this change will any change we make now will also be consumed downstream as well by CNC nesting and so forth like that. Finally, what we're going to do is just a framework around this. We're just going to actually combine it into assembly and mirror this across to complete the overall assembly in place, and we're going to restructure the assembly components for our bill of materials at this particular point. I'm just going to move on. So The big thing about Inventor, and we use Inventor, Inventor is very much focused on the solid part and creating up solid parts. So you can see here, as I go along, we can model Inventor, we develop a part. So the part is generated like that, and is listed as a BOM part on your bill of materials, I should say. But if I move to Inventor, woodworking for Inventor, you can see not only does it do the part, but it also breaks it down into sub. So you got your top cover, core material, bottom cover, edge banding, and paint. So and paint and lacquer, for example. So this is just one of the areas that we wanted to look at. So it's very important that we establish for our bill of materials that we have this information up front. In this case, the next part of my presentation is very much focusing on that. So again, I have a quick snippet here whereby I'm going into the library, picking which I want, laminate, multi-layer. It could be for edge and then edge banding, for example. And in this case, you can see I'm picking the veneer, I'm picking the style of veneer I want. I can assign it to the particular bodies or parts that make up the particular assembly. And you can see then I can pick from the choice here where I can specify a board. And in this case, what type of board? This is a rectangular profile. You can see here. In this case, we're picking the frame. And again, that can be applied on multiple bodies and filtered out. You can see then pick a board. I'm going to pick a laminate type board for the top, and again apply it. And again, all this information is captured in the bill of material. I can isolate parts and filter parts so that I can work with and select specific parts. In this case, I'm working in the internal body. Again, I'm coming along and specifying a laminate board and specifying the type of board that I want. I'm also going to come along here. Once I've applied that, I'm now going to look at the edge banding. So in this case, I'm going to specify edge band, and I can determine what thickness of edge band as well and apply to the relevant faces or edges that's required. So again, you can see very quickly we can apply those. And again, as I said, the bill of materials is consistently being updated at all times. So you're going to have a fully fledged bill of materials with all this information up front, both for manufacture and for design. So you can see now as a result of that, we're just doing a verification check that all edge banding has been applied. And we're just going to undo the isolation and bring it back to show you the entire model. And then what we can do is we can even come along here and apply the edge banding to other areas, which is the external edge banding on front and back of the actual workpiece itself. The other good thing about this as well, when we look at this, we can also determine what the grain is going to look like. So for example, here we can control the grain or orientation, especially on the drawer panels here. So you can see very quickly, I can specify the drawer panel. And then what I can do, looking at one switch, we can come along here and we can change the orientation of that particular grain, and that applies to all similar occurrences of that particular drawer in the assembly as well. Moving on from that, I think Tobias, would you mind taking over here for a second for you're doing the library practice?
Yeah, no worries. So just to touch on the library part of it. I mean, so Woodwork for Inventor comes with its own library. Obviously, there's about 300 components kind of come in as standard anyway. But if you have any existing Inventor products that you already use, any kind of bespoke handles or anything like that, that can always be brought in with the sculpting rules to be applied as well. Similarly, if you have any suppliers that have 3D models, not necessarily within Autodesk, but using any other 3D model, it can be brought in, it can be converted into a Woodwork for Inventor model, and again, sculpting being curated around that. Now, it does obviously take a little bit of time to do that, but just to give you guys an example, like if you were to bring in a screw and try to put all the sculpting associations with that, that would maybe take about a couple of minutes tops. Maybe a hinge might take 10 to 15 minutes, and then it just kind of increases with the complexity of the product. Now, here's some examples of some cam dowels and locks really that are already within Woodwork for Inventor. So as soon as you kind of put these in, it'll automatically take out the sculpting. There'll be a video shortly to show you, but you'll see that all the material that is not necessary is already removed, and that's also available to be seen in the final drawings as well. And again, just in terms of hinges, these are a number of hinges that are already available within the Woodwork for Inventor library. And then just in terms of mounting holes, I mean, there's a lot of different things that they can do in terms of all the hinges, also the joints that you can see there, the woodworking joints. You can adjust tolerances to suit, changes can be made. And like I said before, if you make any changes in the skeleton model beforehand, it pulls through, and also any changes at this stage will also be updated in the drawings at the end.
Okay, I'm going to take this part, which is just a live presentation. This is quite a lengthy AVI, but I'm going to try and speed through it as much as I can. You can see here I'm just isolating components from the assembly environment again. I'm just going to focus on just positioning planes in relation to the byte. This is just positioning our position holders for where we're going to put in our hardware. So you can see here very quickly, I'm just putting in that. And I'm also going to do the same for the shelving, where I'm going to put a kind of a mirror plane where it kind of reference in the center of the shelving that we can position those particular fixings and fittings as we go along in the model. For me as a user of Inventor for years, this is hugely powerful for me. You can see I'm just going to attach, you can select from a component library directly. You can see I can pick what dowels, mini fixes, for example. I can control the size and shape of those and the position of those as well. You can see here by selecting relevant geometry, I can select the top and bottom on the undersides of those boards, or those panels I should say. I can select the sideboards, and then I can select the axis plane, which is basically the position as I just discussed, where we can just position those particular components in place, and we can just attach directly to the model. You can see by the preview there, it's automatically been put in. It's automatically put in the clearance holes as well for you in relation to those particular components. I continue on, and we're going to repeat the same steps for the back. And not only are we going to do that, but you can see very quickly, it's a very simple process for the end user to specify where we want to put those fixings in place. Once we have those in place, now what I want to do is want to filter it even further. And what we really want to do is, you can see here, we're looking at the components that are actually put in. And this is just literally seconds to put this information in. We can isolate those particular components, we can review, and we can actually change the orientation of those components spec by spec. And we can also even using the iMatch utility to actually match those with other fixtures that are already in place within that particular environment. So as you can see very quickly, we can update the assembly, we can update the components, we can change the orientation, and we can complete the fixture settings within the particular carcass and on the body there, for example. So once we have that done, now you can see I'm going to come along, I'm going to change the size and remove one or exclude one of the components. And again, I'm going to use the iMatch to modify the other components that I would like to exclude to occur on. Again, I can filter out the components and look, and now what I'm going to work on is I'm going to work on the holdings for the shelving. So in this case, what we can do is we're looking at the particular information. We're going to again attach a particular type of holder. We're going to specify the holder type that we want, and you can see, you can specify the whole number that we're going to use per panel. We can specify the board locations, again, the central board, for example, and then we can specify the top and bottom planes to suit as well. So again, the bottom planes in this case are the underside of those shelves. So once we come along, we specify the location planes, and we attach those holders in place like so. So again, that's just kind of a quick example. There's a lot more to this, but I'm just going to speed this through if you don't mind, because it's the same principal steps. You can see here now what we're doing is we're going to actually put in a double dowel miter on the joints, and we can actually again size that, put that in position. And you can see we can choose the size from that. What we can do is we can select the location by selecting the boards and so forth like that. And again, we're specifying the top and sideboard to position in place. I'm just going to let this finish out, and then I'm just going to move very quickly onto the end result of all those components in place, just to kind of give you a feel of where the wireframe view is. So again, you can see it's put into position there. I'm just going to speed this through, folks, if you don't mind. And you can see we're just going to continue on and pattern those about the other faces as well. Just there. To finally, where we can look at the view, we do a quick sculpt on all the particular library components. So that will actually put in the holes in place for us, and for the clearance holes and so forth like that. And if you can see here now, when we move to a visualization of the wireframe, you can see very quickly the detail on that particular assembly. So that's where all our fixtures and fittings and using the library, with the built-in libraries would work Inventor. And I have to say as well, it is customizable. You can add your own components to that, and you can build on that as well.
Okay, thanks. So we'll try and quickly run through the rest of this. Obviously, some things at the end as well we want to cover. So in terms of bill of materials, as mentioned earlier, they're all kind of completely customizable, configurable. You can get your own cutting list, edge banding list, grain directions, material codes, and you can even see what side that the edge banding is on within that within those bombs as well. Yeah.
Okay, perfect. Great. There you go.
Thanks very much. And yeah, just material replacement again. This is just touching quickly on what I mentioned earlier. Changing the material as a whole. So obviously you assign the material in the first instance, and then once you actually have the final model, there's a lot more material or even colors in the material replacement library. So you can obviously change that front from being light to kind of dark gray color if just in terms of when you want to present it to your customers.
This is a good example of this, where what we've got is we've got just a, so you can see very quickly what it can do. We can do a replacement option. We can select, it does a kind of verification check on the assembly at the minute. What we can do from here, we can set up a new configuration. And in this configuration, we're going to set up a dark facade. So in this case, what we're going to do is we're going to change the appearance and the material assignment in this particular case. So what we're going to do, and this is probably one of the most important ones, whereby I can go in, I can look, there's a number of set templates directly built into Woodworking Inventor. You can see we can collect those templates. We can do some certain mapping for appearance on our exports to bill of materials, for example, or appearance codes, appearance name, for example. And what we can then do is we can come along, once that's set up, we can then define what kind of veneer we're going to use, or what kind of appearance are we going to use, and you can categorize those and filter those to particular colors, for example, and to particular segments within the particular body in the back as well. So for example, we can control for the internal components in the body, the external components on the unit at the back, and any veneers we want in the particular. So you can see it's constantly updated there. You can see we get a preview of what it's going to look like before we actually generate the BOM. So from here, once we have those generated, once we have the appearances updated and mapped, so we've replaced the materials, we're now going into the BOM, the bill of materials, which is important. Again, you can see it's much extensive, where we can specify what type of BOM we want to use. And in this case, when we generate the BOM, it will give us a pretty comprehensive BOM where we have, for example, the component structure number 1, which is key. We've got a complete parts list. We've got a material summary, which you can see coming through next. So there's a complete parts list, our cutting list, as I said, and a material summary, which is it's very extensive. It's very good. Again, experience of BOMs from the manufacturer side. This is a very good, quick, and clean way of generating BOMs of a very detailed assembly. So it gives you quantities, thickness of the veneer, and as Tobias said, the side in which that veneer will be on as well. So that's that edge banding will be on as well, I should say. Sorry. Finally, on this, you can see we can get, one of the most important things is a price list. So you can see the last element of this is, again, doing a complete selection of the assembly, looking at the BOM. And again, what we're doing is building a template for price calculation. And as per the template, you can see to build the BOM, and it will give you a complete price calculation on the actual unit to build. Okay. And again, I'll move forward in this.
Very good.
Okay.
So Ray, it's a new software solution from Procad. Is it just launched, or has it been on the market for a short amount of time?
It's been on the market for a bit. To be fair, I think Tobias is probably best to answer that question. But yeah, this is something that we are working closely with Tobias on to bring to the Irish market. This is we've an awful lot of customers that are within the furniture industry or in the woodworking industry that are using Inventor, and I think this would be a nice addition to some of those customers as well, and the benefits of that. I think Tobias, would you like to jump in on that as well to answer that question?
Yeah, I mean, Woodworking Inventor has been around for a while now. So we work with a couple of different customers within the UK who have it. It actually comes from Europe originally, but we're trained up in it over here, and we actually run through it with a couple of different customers. We actually have an example later on as well. I don't know if we want to kind of skip along to.
Yeah, I think we might. We think we're running close on time, Michael. Is that correct?
Yeah. Yeah, no, we'll be running, and needless to say, we'll be circulating a recording of the presentation, and obviously details and information. So it'll allow our members really to have a further look and follow up with any interest or queries, hopefully from that point of view. So it's a fantastic presentation, a lot of information there. For me, it struck me the customizable piece is probably important to a lot of people, particularly in this day and age, but certainly the context of digitizing work, an important element of the process. Thanks.